So I'm sure you've heard that antioxidants are really good for our health and they help to keep our cell membranes healthy. But this is to talk about why is that the case. If you're interested in understanding exactly what it is about antioxidants that we get from our food, why are they so useful in keeping our cell membranes healthy, and why are they even more important if you are consuming some PUFA. Now, just to reiterate something you may already know, PUFAs stand for polyunsaturated fatty acids, and actually many of them are required in our body. They are actually essential. Like, for example, EPA, DHA, fish oils are actually a form of PUFA. So some of them you actually do need, and of course there's a lot of talk about how we should be trying to avoid seed oils from vegetable oils, things like that, because they do contain PUFA. Now, the interesting thing about these types of fats is they are polyunsaturated fats. They are very long chain fats. And what's different about these as opposed to saturated fats is if you imagine a big long string of carbons, a carbon chain, each carbon has to have 4 bonds. And so if some of those bonds are missing hydrogen, so if it's fully saturated, every single bond is going to be bonded with a hydrogen. But if those hydrogens are missing, it means that some carbons have to essentially share a bond, and so this forms a double bond. Now, what's interesting about a polyunsaturated fat is the carbon in between the double bonds are susceptible to oxidation, essentially. They're susceptible to an oxidant molecule coming over and stealing some electrons via hydrogen. Now, why this is relevant is because the stealing of the hydrogens from the PUFA, from the fat, ends up turning it into something called a lipid peroxyl radical. And this essentially means that the hydrogens have been stolen off the fatty acid molecule, and then instead things like oxygen can come over and bind, because they're also looking for electrons as well. What then can happen is then this propagation can occur, which essentially means that the fat itself, the fatty acid itself that originally lost the hydrogen and the electrons, is then going to be like, I'm missing them, I need to find more. So then it goes on to stealing more electrons from another fat nearby. And the reason it's called propagation is this continues to propagate. Each time that a fat gets electrons removed, stolen from it, it's then wanting to replace them, so it keeps propagating and keeps stealing it from other fats. And this will just keep going on and on and on until eventually all of the fats within that cell membrane, if they are polyunsaturated, they will just have this occurring to each one of them. And this, for what it means for our health essentially, is that if you imagine the cell's membrane is entirely made up of these polyunsaturated fats, which more often than not it is, then this damages the cell membrane. Essentially, the membrane stops working properly, and you can actually have forms of anemia called hemolytic anemia, which is essentially where this occurs. There's an inability to stop this propagation occurring. The cell membrane gets completely annihilated, and we can't essentially keep the contents of what's inside the red blood cells from spilling out into the surrounds, and this is hemolytic anemia, or this is a cause of hemolytic anemia. But what's also interesting to note here is that these fats can keep propagating, or they can also fragment into something called, and I'm not going to be able to pronounce it, but it's called malondyl aldehyde. I think that's how you pronounce it, but it's essentially just fragmented versions of these types of fats. If you imagine, the best analogy I've heard from Dr. Chris Masterjohn actually is that it's somewhat like glass. So you have glass, which is the PUFA, and that is a fragile thing, but it's okay until it breaks apart, and then it can be damaging. So if that fat was to break apart and fragment, it can then go around the cell and actually damage other parts of the cell, much like a shard of glass would be damaging to our body. But this is the point of the talk, is our antioxidants. Why are they useful? Well, in this situation, what can happen is that if we have enough vitamin E's job is to essentially sit in the cell membrane, and when we have damaged a PUFA, it will then give back those electrons or the hydrogen that was originally taken. This is why vitamin E is so important, and it's actually even more important when you're consuming more PUFAs. If we have more vitamin E, we have more of a capacity to then recharge the fat, essentially give back those hydrogen electrons that was originally lost. But what happens to the vitamin E then? So the vitamin E gives up hydrogen, electrons, and now it's oxidized itself. So does that continue to propagate the issue? No, because then what comes to the rescue is vitamin C. And in exactly the same process, vitamin C then is oxidized and it gives up some electrons, gives it back to the vitamin E so that the vitamin E can keep handing them over to fats that are getting oxidized. But then the same thing happens. The vitamin C has become oxidized now. So who comes to the rescue? Well, something called glutathione then comes to the rescue, and that will donate to the vitamin C. So essentially, in order to prevent your fats from continuing to become oxidized and damaging your cell membranes, we require certain antioxidants, and they are vitamin E, vitamin C, and glutathione. And actually, the three of them work together in order to help to regenerate and prevent any more oxidation of those fats. I will say they can't actually prevent the initial oxidation, but they can prevent it from getting any worse and from really damaging cell membranes and things like that. Something else I want to point out as well is that one other enzyme that actually helps us to prevent further fragmentation of the fats is something called glutathione peroxidase, and that is actually selenium dependent. So not only do we require vitamin E, vitamin C, and glutathione for helping to prevent our cell membranes from becoming oxidized when we are consuming our PUFA, we also require selenium. So in summary, we do actually require some PUFA. Some of them are actually, we can't actually make them in our body, much like examples here would be, fish oil, EPA, DHA. We do actually require them from our diet. So we do require having some PUFA in our body. We can't completely avoid PUFA. While you don't really want to consume lots of vegetable oils, you do want to consume some PUFA from, for example, EPA, DHA. But it's the antioxidants that we get from our diet, including vitamin E, vitamin C, glutathione, and selenium that help us to prevent these from becoming further oxidized.